There are three ways to solve physical contradictions. As I just mentioned, separate the contradictory demands. Another could be satisfy them, somehow satisfy them. They are contradictory in nature, but still you could be able to satisfy them. We will see. Or simply bypass contradictory demands. So let us first look at separating contradictory demands. We separate contradictory demands by answering these 5 questions. So the hammer should be heavy, the hammer should be light. Where should the hammer be heavy? Where should the hammer be light? Okay, when I am hitting the hammer, when it hits the nail, at that point it should be heavy. Where I am holding it should be light. Okay, let us think about it. Then separation in time. When should it be heavy? When should it be light? Okay, when I'm doing this, then it should be light, but when it hits, it should be heavy. Can I do this? I don't know. Separation relation. For the nail, it should be heavy. For me, it should be light. Separation in direction. Can I separate? In which direction it should be heavy? Or in which direction should it be light? And then the fifth is separation in system level. Now for this, there is no key question. You just see, could the properties actually be separated from microsystem to super system level? Can you transfer some of the requirements, one of the contradictory requirements, to either the micro level or the super system level? There is no key question. It is just that, can we do it? And if we can, we apply the separation and system level solutions. Okay. Let us look at this separation in space. So if 2 contradictory demands are required in different locations, that is separation in space. And the principles that you use for solving them are segmentation, taking out, local quality, nested doll, asymmetry, and another dimension. So tell me one thing. How many of you have used the tech optimizer tool or the matrix yet? Have you seen the 40 inventive principles? Those of you who have seen the 40 inventive principles, at least made an attempt to search for them or identify them, can you just put a +1 in the chat window? Okay, I get that. Thank you. Others have not yet even opened the tech optimizer tool, it seems. So how many of you have installed that, opened the tech optimizer tool and experimented with it? Can you put a +5 in the chat window? So I think as project teams, you're not yet at a stage where you are looking at finding solutions to your problems. That's why you've not even tried to open the tech optimizer tool. Tech optimizer tool has this contradiction matrix already inbuilt there. It has methods to make your function diagrams very quickly, function models very quickly. It also guides you as to, in terms of value, which ones to trim, which components to trim, and which components are worthy of trimming, and so on. So I would again strongly recommend that please open it. Otherwise, next week we have the final or the midterm presentation. How will you handle that? You will have to show something there. Please do that. So these are the principles which are used to solve the contradiction by using separation in space. Then separation in time, where we say that the contradictory demands are required at different times. Can you? So okay, before that, do you remember we worked on an example for separation principles when I was introducing TRIZ? What example was that? You would bore a log into sand into frozen soil. Yaad hai?
Yes, sir. Yes.
So when do you need the log to be sharp? Or where do you need the log to be sharp? The head of the log to be sharp?
While digging, like while
That
fixing
it penetrates inside.
Okay. So see, you realize when you are answering this question, I asked where, and you responded while.
At the bottom, most at the tip.
Yeah. No. So what does it mean? This means that the principle that you should apply is separation in time, not the separation in space. Whereas you could have said, okay, when the log is on the surface or at a depth higher than what I want it to be, it should be sharp so that I can continue to dig. When I have reached the required depth, it can be blunt. Are you able to see this? The answer could be in terms of where also. Where is it required to be sharp? Where it is still going down. Where is it blunt? Where it has reached the required depth. So if you apply one of these principles over here, what would that be? You know the solution already, is it not? The solution was put something in between. Put something in the, what do you say? In the head of the log, and then blow that dynamite away. So what inventive principle is being applied there?
Nested dolls.
Nested doll. That you are applying the nested doll principle, that there is something nested inside your material and you use it then. Okay. So next we come to separation in time. There are separation in time, and the inventive principles that are used to solve this kind of a problem are preliminary anti-action, preliminary action, in advance cushioning, dynamics, and discarding and recovering. So now let us experiment with the same problem. You said when I'm digging, it should be pointed. When I'm not digging, it can be blunt. So what principle, which of these principles could have taken you to the same solution that was used there?
So the first one.
Preliminary anti-action. Why do you say so?
So because action taken while boring and when it is down there is different, because first we want it to be sharp, then we want it to be blunt.
So if it was like preliminary anti-action, matlab, I want it to be blunt, but that blunt I will ensure later. So for that, to be able to do it later, I need to take some anti-action now. I need to make it sharp, and I would add some material inside so that it becomes blunt later. Okay. This could also be called as preliminary action. Basically, you prepare for something later. Okay. So embed the explosive within the logs. This is the same problem that you're talking about. Embed the explosive within the logs. Blow it once the desired boring is done. So you could say it is a nested doll principle, or you could say we have already preempted this problem and we have already taken appropriate action before even putting the log inside. You with me? Any questions still here?
So for separation in time, we had one principle which was, so could you please move back to the previous slide?
Yeah.
So this discarding and recovering, can it not be this one?
Can be. See, once you know the solution, you could say this inventive principle was also used. Going back is always easy. Going forward is the problem.
Right.
Do you see this?
Yes.
Going forward is the problem. Vapsi mein to you can always connect it to any principle.
Right.
So yes, it can be this. But discarding and recovering is typically meant for example, there is, if you are running a program You put some data inside your L1 cache or something like that. You brought some data, and then you don't need this data after some time, so you discard it. If you need it again, you will access the memory again and you will bring this data again. That is typically like discarding and recovering.
So because in this one we are discarding the sharp edge and then recovering to get.
You're not recovering the sharp edge again.
Okay.
This is for reusing. This is for reusing this inventive principle. So again, if you will open the tech optimizer tool or use the inventive principles handouts or anything, you will see that all these principles are explained with a few examples. That will make these, otherwise so एक word से आप कितना कुछ, you can imagine so many things out of this one word. What did Altshuler mean? He has exemplified it with 3 or 4 embodiments. Each principle he has done that. So it will be easy for you to understand what discarding and recovering means. Okay?
Yes, sir.
So what I will do is I will also share on Classroom another sheet which has the description of all these inventive principles. So even if you're not open the tech optimizer tool, you can look at that sheet to get the reference there. Okay.
Okay, thank you, sir.
So now we come to separation and relation. What do you think? What was the key question for separation and relation? What was the question? Separation and relation? Abhi to kara. We would answer the question for whom. So separation and relation meets, or if the contradictory demands are required for different components of the super system or something like that, you say, okay, for the person at hand, this is what is required. For the nail, something else is required. So you're talking about separation and relation. And the principles that are commonly used to solve physical contradictions by separation and relation are local quality, or moving to another dimension, or periodic action, or using porous materials, bringing about color changes, using composite materials. All of these are separation and relation. So for example, composite material, the material that is facing the inside is giving one property and one chemical property. The material on the outside is giving the other chemical property or other physical property. Porous materials can be used such as that in those pores that you have, you could fill something else. For example, one chemical, this is the base chemical, but in these pores you are filling something else, so that the property of the other chemical is also available, which can be a solution to the second requirement, and so on. So this is about separation and relation. An example of this is also we discussed the changing color was thing that we had discussed in the previous session also. When you're driving on dark roads, the cars coming from the other side can actually be a glare and can glare you and can lead to accidents. So you do not want high beam, but you want high beam because you want to drive fast. If you go on low beam, you will not be able to identify pedestrians or animals, and therefore you cannot drive fast. So for the same beam of light, you want it to be high beam and you want it to be low beam. Now, for whom do you want it to be high beam? For whom do you want it to be high beam? The driver coming from, for the pedestrians. Who do you want it to be low beam? For the driver coming on from that side. So, okay, keep the visible range light in low beam and infrared light in high beam, and you will be able to solve the problem. You remember this? So you change the solution or offered a different solution for different relationships there. And which inventive principle have you used? Which inventive principle have you used?
Different dimension.
Color change. Infrared is infrared color, like still lesser wavelength than red, and visible light is the visible light range. So you're just changing the color.
Yes.
Okay. So then separation and direction. If the contradictory demands are anisotropic in nature, that is, in one direction you want one behavior, in another direction you want another behavior, then you can use these principles to solve the problem. Asymmetry, curvature, parameter changes, another dimension, color changes, and so on. You want to look at an example? For example, a baby's diaper. What do you want? It should have low hydro resistance to collect the liquid, but should have high hydro resistance to prevent leakages. So what is the solution there? What is the solution? You say when the water is coming from this side, it is able to see less resistance, but when water has to go out, it sees much more resistance. So directionality. So a diaper has super absorbent layer, as you rightly said, where breaking this layer would then be very difficult. If something is absorbed, coming out of that would be very difficult. So multiple layers to solve the problem. This all of us have seen. What is this? गुल्लक. तो इसके अंदर डायरेक्शनैलिटी वाली प्रॉब्लम सॉल्व हो गई है?
Yes, sir.
It should be easy to put the money in. It should not be possible to pull it out.
Yes, sir.
Easily solved here. है ना? If you want to take the money out, you have to break it. So the next way to handle these contradictions is separating at system and supersystem level. The typical solutions are segmentation, merging, equipotentiality, and homogeneity. And the example, again, as we had seen earlier, was iron is rigid but strong. We need the strength of iron to make a good rope, but I also need that rope to be flexible to run around a gear or a pulley. So solution was segment it into smaller nuggets so that the chain is strong, but it is also flexible. Are you able to see this? Any questions? Okay. So until now, we were looking at separating contradictory demands. Let us also look at satisfying contradictory demands. How do we satisfy contradictory demands? So if you want to, if you cannot use any of those separation methods, then we have to see if there is a possibility to satisfy both the demands. If you're not able to separate, so when we were separating the demands, we were still satisfying both the demands. Do you realize this? Yes. We were already satisfying. Now we are saying we are not able to separate, but even then we want to satisfy. Now let us see which principles are used. If that is what you want to do, then you can use any of these principles over there. The other way around is one of the most powerful principles that personally I have come across. Okay. This, if I have to think the other way around, it really breaks my psychological inertia big time. So you look at these inventive principles to be able to solve the problem. Let's look at an example. So swimmers need to train for long distance events. And So what do you mean? What do you need? You need that the swimming lane, the length of your pool should be very long so that you can run 1500 meters in one go or something like that. But you cannot have such big swimming pools everywhere, can you? No. So you use the principle of the other way around. You say, by the analogy of the treadmill, again, you can run kilometers in a treadmill, but you're standing in one place only. In a space of 10 meter by 10 meter, you could be running 1 kilometer, 2 kilometers, 7 kilometers, all of that in a space of just 10 meter by 10 meter. So can we use the same analogy for swimmers? Yes, you could have a tread swim where the water flows. The water is there. There is water which is flowing. So as you swim, you're not really physically moving, but the water is moving forward so that you get the same experience as if you were running or as if you were swimming long distances. So do you realize this could not have been done by any of the other separation principles? You needed this space. In the same space, it has to be long and it has to be small. At the same time, it has to be long, it has to be small. It is for the swimmer that it has to be long, and again for the swimmer also it has to be small. So you could not have done anything else. And that is where you're satisfying both the demands by using the principle of the other way around. Okay, are you able to see this? Any questions? Okay, so let us also look at, there are situations where you may need to bypass contradictory demands. How do you do that? Let's see. So if the contradiction cannot be resolved by using separation or by satisfying both the demands, we have to explore if it is possible to bypass the demands. So you look at new solutions which make the contradiction irrelevant. Yes?
So, from the previous PPT, so every time do we need an analogy to compare and then
No.
to answer that? Since you
So
told us that we need
yeah.
an treadmill. Yeah, yes, sir. Please.
Yeah. So over here, I just give this analogy because
okay.
Yeah, I give the analogy because all of us are very well versed with the concept of a treadmill. You don't need it. I just gave this analogy just to bring home the point that this principle is used not only for the swimmers, it is also used for runners, it is also used for other people. So instead of swimmers, I could have simply used athletes or runners over here. I chose to talk about swimmers because I felt that treadmill तो आपको सबको पता है. Swimmers का भी ऐसा कुछ होता है आपको पता नहीं होगा. That was why. Nothing else. I wanted to bring something new to you.
आंसर अगर किसी का सॉल्यूशन ही अगर कुछ ना हो तो फिर उस सिचुएशन में क्या करेंगे इफ यू डोंट हैव एनीथिंग टू कंपेयर विद
तो उसी के ऊपर आ रहे हैं. You bypass the contradictory demands. If nothing else, if neither the separation principles work and you're not even able to satisfy both the demands, then you bypass them. You look for new solutions which make the contradiction irrelevant. Okay. Let's take an example. A boat should be thin to be able to move fast so that the drag is lesser in water, and the boat should be wide for balance. Do you understand these two demands? That if the boat is wide, it is much more balanced. Is it not? It will be very difficult to topple it. But if the boat is very thin, it is easy to topple it. How many of us have done boating? Put a +1 in the chat window. Ever sat in a boat? So from your experience, can you say that a very thin boat, it is difficult to balance? And if it's a wide boat, then it's stable? Can you say that? So Rutvik is saying it has to be stable. It should be wide first. That is the first priority. Speed it has to be stable, otherwise it will topple, it will capsize. So very true. Stability is a very key criteria. And we want to still move fast. So one of the ways to bypass this is, for example, a hovercraft. So what is happening here? It has a mechanism so that it does not go deep into water. In fact, it just hovers above water. It pushes a curtain of air, or curtain भी नहीं, I would say a pura surface of air, it pushes so that it rises above the water, and then through these propellers it moves forward. So now the contradictory demands do not even arise. You do not need it to be thin at all, because you're not even in water. Are you able to see this?
Yes, sir.
So you come to a completely new paradigm. That's a paradigm shift that you look for. How can I remove one of these problems at all? Oh, if I was to travel on water but not inside water, how could I do that? Oh, I could float on water by pushing, the water down, or pushing on the water so that I am always levitating. You heard about magnetic levitation? What does it do?
Yes.
It raises the train above the track, so there is no friction now. See, until the time that the train is touching the track, you need some friction so that the train can, until there are wheels, you need friction so that the train would move forward, is it not? But you also do not need friction so that you can move forward, so that you can move fast. Do you see? It's a contradiction. At the same place, same time, same objects. And maglev solves that. Magnetic levitation solves that. Just today, I was reading that in China, they have developed a maglev train which is 600 km per hour. It would reduce the time between Beijing and Shanghai to 2.5 hours from the present 6 hours, or something like that. So that is also bypassing contradictory demands. Now the contradictory demands don't even exist. Okay. Clear?